Learn Docker from scratch in 7 concepts in 2 minutes. So your application works perfectly on your laptop. Then another developer runs it and it fails. Is it the wrong version? Are packages missing? Are we using different system libraries? Or database is not configured? The code is same, but the environment is not. That is the problem Docker solves. Let's learn Docker by shipping one real example, a Python API connected to a PostgreSQL. The first concept is containers versus virtual machines. A virtual machine includes a complete guest operating system. A container, on another hand, packages your application and isolates its processes while sharing the same underlying host kernel. That makes container lighter and generally faster to start. But a container is not simply a tiny virtual machine. It's an isolated process environment. So if you want to package our Python API, that will bring us to images and containers. An image is an immutable package containing your code, runtime, dependencies, and default commands. A container is a running instant of that image. Think of the image as a blueprint and the container as what you get created from it. One image can start many identical containers. But the question can be, how do we create images? With a Dockerfile. It's the build recipe for Dockers. Keywords like from chooses the base image, work directory sets the working directory, copy adds files, run install the dependencies. CMD defines what starts when the container runs. A Docker build turns this Dockerfile into an image. And Docker run command starts a container from it. Now there is another problem. If we change just one line of the code, should the Docker reinstall every dependency again? No, because the images are built in layers. Each Dockerfile instruction creates a reusable layer. If it is not changed, Docker reuses it from the build cache. That is why the Dockerfile order matters. Copy the dependency files first, install dependency, then copy the frequently changing source code. Now a code change does not invalidate the expensive dependency layer. Now your API runs inside a container, but Postgres creates another problem. Containers by nature are disposable, but database data cannot be. That is where volumes come into the picture. A volume stores the data outside the container's writable layer. So you can replace the Postgres container without deleting its database files. Containers provide replaceable compute. Volumes provide persistent data. Now the APIs need to reach to Postgres. This is where Docker networking comes into the picture. Inside a Docker network, containers communicate using service names. And to access application from your laptop, publish a port like 8080:8000 / traffic from port 8080 on your machine to the port 8000 inside the container. So we now have API, we have Postgres, we have volume, we have networking, we have ports. Running all this every time manually would require several commands. That is where Docker Compose comes in. Compose describes the complete application in one YAML file. Then only one command starts the entire stack. That is called Docker Compose up. So here is the complete Docker mental model. Dockerfile builds an image packages the application, the container runs that image, layers speed up the build process, volumes preserve the data, network connects services, and Docker Compose runs the complete stack. The purpose of Docker is to give software repeatable runtime. So instead of saying it works only on my machine, you can actually ship the application environment with your code. Comment Docker if you want resources to get started on this, and follow me for more.